Hello everyone, and welcome to this short demo, showcasing how the LinkScope investigation software can be used by cyber incident response teams to detect and respond to network-based attacks on our infrastructure. In this scenario, we have been notified by a user that they have received a suspicious email from an unknown external entity. The user reportedly checked out the email and opened the attachment within before contacting the security department. We have been tasked with investigating what exactly has happened and see if we need to worry about malware running on the network. For this demo, we have access to a recent packet capture that we can drag and drop into LinkScope. Normally, you would have access to NetFlow data instead. The investigation process will look largely the same, but packet captures allow us to also analyze unencrypted traffic. Additionally, we will import a list of logging servers for us to pull logs from. We happen to have just one logging server, which is running the Elk stack. Finally, we will manually create a new entity with our public-facing server's IP address to see if we have any uninvited guests. Now that we are all set, we can begin the analysis. Let's start by looking at the captured network traffic. Since we have a packet capture, we could begin by looking at the low-hanging fruit, extracting transferred objects over unencrypted connections. Not all threat actors maintain a high level of care and diligence. We could potentially get an easy win this way. We can also go ahead and extract logs from the Elk machine. And finally, let us get the IPs currently connected to our public-facing server. Now that we have all this info, we can begin our analysis. Let us ungroup this set of entities and see what kind of traffic has been going on in the network. That's quite a lot of transferred files. While they might all be interesting to review, we should prioritize inspecting the file types that are the most concerning. Archives. First, we'll use regex to select non-archive file entities. Then we will select the parents of those file entities, which would be the network addresses that sent the files. We will then hide these network addresses from this canvas. Hiding entities means that they remain a part of the project, but they are not shown on the current canvas. Then, we will select all the isolated nodes on the canvas, which would be the file entities, and hide them too. There's easier ways to do this, but this way lets us show off various different ways of selecting nodes, as they might come in useful in your investigations. Let's turn our attention to the network address where most of the archive files were sent from. We can collect threat intelligence on it by querying VirusTotal about its reputation. We can see that the IP address is Russian. Considering the current state of the world, this is probably not a good sign. Several of the scanners on VirusTotal also classify this IP address as malicious, another red flag. We can also get information from VirusTotal about domains. Let's see what it can tell us about this one. We can see that the reputation of this particular domain is not very good, which is worrying. Speaking of address reputation, we can also check if any of the network addresses in our logs are known Tor exits. While there are legitimate reasons to use Tor, in this scenario we do not expect any traffic from darknets, so seeing that we have established connections from there is a red flag. At this point, we can see that we have some traffic in our network from sources with poor reputation. Before we take any action, let us also examine the files that were sent over the network. In order to get a clearer view of this situation, we can rearrange the items on the graph as a timeline. The resolution we ran that extracted files from the packet capture set the creation date of each object to the time that they were sent over the network. By rearranging the items on the canvas by date created, we can see that the file called client.zip was the first item to be sent over the network. Let us examine this file further by uploading it to VirusTotal to check if it is malicious. And as we can see, a lot of the anti-malware engines on VirusTotal report this file as malicious. If we wanted to double-check, we could submit the hash of this file to hybrid analysis. If present in their database, we will get a verdict telling us if the file is malicious or not. And indeed, we can see that hybrid analysis tells us that this file is, in fact, malicious. Remediation is out of scope for this demonstration, but we can briefly show that we can block the Tor exit node connecting to our server by adding an IP tables firewall rule to drop packets originating from that address. Since this command has no output, we can verify that the rule was added by listing the rules in IP tables like so. And as we can see, we are now blocking traffic from that IP address. Everything that we just showed here today can be further automated through the use of macros. Macros can chain together resolutions that pull logs from various sources, inspect traffic, block malicious IPs, and more, so that running your incident response playbooks can be done with a single click. If you're interested in learning more and diving deeper into more complex scenarios, you can contact us on our website and follow our blog for more informative videos like this one. Thank you for watching, and have a great day.